Okay, we're now going to look at how you define and find points of intersection for parametric equations. If we look at this example taken from the textbook, the diagram shows a curve C with parametric equations x is equal to at squared plus t, y is equal to a brackets t cubed plus 8, and we're told that t is any element real, where a is a non-zero constant. Given that c passes through the point -4, 0, find the value of a. Well, we are given that x is equal to at squared plus t and y is equal to a brackets t cubed plus 8. We're also given an x and y coordinate where that must be so at that point -4, 0, t must be the same for both of those for that curve to pass through that point. So we can actually substitute into our x equals at squared plus t that -4 must be equal to at squared plus t, and into our y equals at cubed plus 8 that 0 is equal to at cubed plus 8 for at that specific point. And that's the key to this problem. We're also told that a is a non-zero constant, so if we then substituted these values in to create these two equations from that point, knowing that a is non-zero, we know that it must be that t cubed plus 8 is equal to 0. And solving this, we have that t must be equal to -2. Substituting that into our first equation, we're going to get what a is equal to. So a being equal to -1/2. Part B, find the coordinates of the points A and B where the curve crosses the y-axis. This is a really common problem where we are asked to define and find where a point crosses either the x-axis or the y-axis. So just like always, you have to remember that at the y-axis, the x is going to be equal to 0, just like at the x-axis, y is going to be equal to 0. If we're trying to find the coordinates of a and b where they cross the y-axis, that must mean that x is equal to 0. We've just found that a is equal to -1/2, so I can substitute that 0 is equal to -1/2 t squared plus t, and that's what we do. Beyond that, we are solving to find out what t is equal to, but it's asked us to find the coordinates, it's not asked us to find out what t is equal to. So once we have found t, we then need to substitute that back into our equation for both y and for x. In fact, we know that x is at 0, so it's just substituting that into our y. Substituting t equals 0 and t equals 2 in, we find what those 2 points are, and always just double check, does this match with what I was expecting for my a and b value to be, and it certainly looks that way. So the key here is to find the value of your parameter t first for these, and to remember to look out for coordinates that you know for your y and for your x, which will be given to you in the question in some way, whether it's subtly about how it crosses, where it crosses an axis, where you know that x must be equal to 0 or y must be equal to 0, or perhaps that it's equal to a specific value or crossing a specific point where you know your x coordinate will take a value and your y coordinate will take a value. So if we have a look at another couple of examples, find a curve is given parametrically by the equation x equals t squared and y is equal to 4t. The line x plus y plus 4 is equal to 0 and meets the curve at a, and find the coordinates of a. Well, when this is the case, we're given what x is equal to, we're given what y is equal to, it's possible for us to write this whole thing then in terms of t, seeing as we're given x in terms of t and y in terms of t. So the key point is whenever you want to solve a Cartesian equation and a pair of parametric equations simultaneously, substitute the parametric equations into the Cartesian one. So for my x plus y plus 4 equaling 0, I can instead write t squared plus 4t plus 4 equals 0 and solve that as a quadratic. As it happens, it's a perfect square, and we can get that t is equal to -2. Don't forget that you're not finding t, ultimately you're trying to find the coordinates of a, so now you know what that t value is, you can substitute it into your x and y. We have a look at another example. The diagram shows a curve C with parametric equations x equals cos t plus sin t, and we're told that y is equal to t minus pi over 6 squared for the given domain of t, that is between -pi over 2 and 4 pi over 3. find the point where the curve intersects the line y equals pi squared. Well, again, we're given a value that y must take. Don't be thrown off by the pi squared here. This is just any old number. Y is equal to some constant value. So we could substitute pi squared in here for part A and solve to find what our t value would be. Are we have to find the point where the curve intersects that line? Yes. So once we've found that t value, that's not going to be our final answer. We're going to have to substitute that value for t back into our x, and our y should give us pi squared. So solving pi squared is equal to our t minus pi over 6 all squared. We get our two values that t could take. However, one of those is outside the domain we were told for t. And substituting that into our x, we find the x coordinate and the y coordinate where this curve intersects that line. Find the coordinates of the points A and B where the curve cuts the y-axis. Well, we know that a curve cuts the y-axis when it has an x-coordinate of 0. So I'd be making 0 equal to this. What would I do after that? Well, hopefully you've decided I would have a go at solving that. Perhaps you've recognised that as I'd have a cos t and a sin t, I'd perhaps be trying to find a tan t. What would I be doing after that, and once I've found t? Well, I'm not going to stop there. I've got to find the coordinates of points A and B where it cuts the y-axis. So I'd begin substituting into my y to find out where those values were, and just double checking things like domain and checking that the t values I'm putting in are appropriate for the domain I'm told that t takes. So that's exactly what we'll do. We'll get tan t is equal to -1, and substituting those values in, that's where we're told our points A and B would be. As it happens, the curve looks something like this. I would have a go at pausing the video now and having a go at this test your understanding question. Okay, hopefully you've had a chance to have a go at this problem. What we asked, the curve crosses the y-axis, so we know x would be 0 at the point A, and crosses the x-axis at the point B. So at the x-axis we know that would be y was equal to 0. Show that A has coordinates 0, 3. Well, substituting 0 into our y and solving, we should have found our value of t was 2, which we could then substitute into our expression for y to get our y coordinate. And likewise find the x-coordinates of the point B. If we'd substituted our y being equal to 0, we could then find our value of t and rearrange to find out what x, and substitute back in to find out what our x value would take. Final bit is to have a go at these questions here. As a bare minimum for this exercise, you need to be doing these questions here, but ideally you really need to be stretching yourself and having a go at these harder questions too. Any questions, post them on Google Classroom. I hope that makes sense, but please do let me know, particularly if you're stuck on a particular question. Thank you.